here is again the Smith chart, and the left-hand side will actually show you the families of circles with the real part, which shown here are essentially those circles. So for example, if I look at those blue circles and I look at the circle right here, I see that the closest number on the Smith chart to that circle is the number 2. That means that this circle is essentially representing the family that has RL is equal to 2, meaning the real part of the load, the normalized load, is 2. And this circle here has the real part normalized to be equal to 0.5, and this one is 0.2, and this one is 0. So that means that the very outer circle has no real part. Essentially, it's purely imaginary load. And then all of the other loads can basically represent it there. There is a circle here. There is a little circle here that has, for example, real part of 50, normalized again, and so on and so forth. Now, similarly, I have plotted and I have rather emphasized the imaginary part on the right-hand side. Now, the imaginary part XL, for example, for this part of the circle, has a value of 2. The imaginary part of this part of the circle has a value of 1, and so on and so forth. Now, you might say, why have you not plotted the entire circle? Why did you only plot a part of it? Well, the answer to that is because I am basically plotting only what is contained within the gamma L less than 1 circle. Remember once again that this guy here is actually the complex plane of gamma. So this is the real part of gamma L, and this is the imaginary part of gamma L. So clearly there is a circle that essentially contains gamma L magnitude to less than 1. And this is this circle right here. So anything that exists actually within this circle has actually a gamma L magnitude of less than 1. Of course, I could have plotted things out bigger than 1, but for any real load, you will never actually reflect more power than you should at it. And that basically means that gamma L in real life will always be less than 1 unless you have a generator. So when people, for example, design oscillators, they will often plot the full Smith chart even outside of gamma L less than 1. But for us, where we're not doing oscillators yet, we're going to restrict ourselves to the circle that you see here. So that's why that circle is not there, and if you were to continue, that circle actually would close something like this. Now, the other thing we need to remember here is that XL is the imaginary part of the load, and a load can actually be inductive. In that case, my XL is actually positive. Or it can actually be capacitive. In that case, my XL is actually negative. And if that happens, then I'm actually looking at the bottom half of the Smith chart. So for example, the XL that you see here has a value of negative 0.5. The XL that represents this circle has a value of negative 1, and so on and so forth. So when you are looking essentially to read the load, and you're looking at both families of circles on the Smith chart, the blue family of circles can actually help you read the real part, and the red or green family of circles can actually help you read the imaginary part. So once again, this is essentially the two families of circles plotted on top of the complex gamma plane. So now you have 3 numbers that you can essentially read here. You can read gamma L, you can read RL, and you can read XL just by inspection immediately.